uses a slightly different parameter that's named maintenance work.
Oh yeah, that's right.
And those are not really related other than the similarities in the name. So workmem, the hash tables that it uses are increasingly being used for things like if you want stuff, if you want the distinct values from something, or even if you want to sort things, you'll discover that it ends up deciding, oh, wait a minute, I have a way I can efficiently implement this using a hash table instead. And hash tables are usually very fast and therefore preferred by a lot of the situations that they can end up getting used. But what this means is that increasingly in newer versions of Postgres, it is making more and more decisions about whether or not it can use the faster ways to execute a query, which involve things like hash tables, based on whether or not it thinks it will fit in memory, and that decision's all driven by workmem. So the thing to realize about workmem is why you can't just go crazy and set to a big number. Workmem is not just allocated per connection. It's allocated per what's called a query node. So when you execute a query, let's say it's sorting something and then joining the sorted version over to something else, that's multiple operations inside the query plan. It's got one that's actually reading the data, it's got one that's sorting the data, and it's got one that's going to be reading the data from the other table, and then it's got one that's going to be joining the results from those two things together. They actually fit together in a tree. So when you allocate workmem, every individual node in that tree, every operation, could theoretically use workmem or the memory. So it's not really a very good bound at all. So the question you have to ask yourself is, well, on the query workload that I have, how many of these sorting operations typically end up happening, or how many of these hashing things end up happening? It's kind of a hard number to measure accurately in most cases. Normally, the guidelines that I ended up coming up with that seemed to work pretty well while developing PG tunes said, well, let's take the total amount of RAM in the server, let's divide it by the number of connections, and then we need an additional number to divide it by that's kind of what's the expected number of concurrent workmem operations that might be happening on any given query, and the range of that number has typically ended up being about 4 to 32 is where you get starting values for this. So 4 would be the right kind of number if you've got, say, a big data warehouse that doesn't really have all that many connections to it anyway, but the connections that are running are processing giant chunks of data that they really need a lot of working memory to do. 32 would be a more appropriate number for, I've got a web application and the number of users varies around a lot, and I want to be a little paranoid about that, and the queries that they're running are not really all that sensitive to whether workmem is set usefully or not. So that's kind of where those numbers come from. I'll talk a little bit later about what I tend to prefer on this stuff, which is if workmem is set too low, you can see evidence of that fact set in the logs. So if you go looking for that information in the logs instead, you can set it conservatively and then look for evidence that you've set it too low and then increase it based on that evidence. I always prefer these sort of iterative approaches where you get in reasonable range, but on the low side, and then monitor the system to figure out if you're too low, and then use that feedback to go up from there. And workmem works very well for that. Last bit of trivia for this section about workmem. Workmem, unlike, well, actually effective cache size is also in this category, but typically not filled around this fashion. You can set workmem for a query. Any query is allowed to set workmem before they run. So the server does not enforce workmem on the clients. The client can say, I need workmen to be this giant number to execute correctly. So what ends up happening in a lot of places is they will set workmen for particular queries that are running giant reports to values that are higher than it would really be safe to set the entire server to. So you might have an overnight batch report or some sort of weekly summary or something like that that you look at and go, man, I look at this query plan and I gotta give it a gigabyte of working memory to get the query plan that executes this thing correctly. A gigabyte is a completely reasonable workman setting for a giant report to run, but you can't set workmen to gigabyte into PostgreSQL.com because then every query operation on every node, on every connection, could end up using a gigabyte of RAM. You're almost certainly going to crash because you're out of memory if you do that sort of thing. So setting workmen, it can be difficult sometimes to figure out where in the hell do I actually set this thing in. I forget the exact version, but one of the newer Postgres versions, I think it might have been 9.0, you can actually tweak this stuff on a per user basis, where you can make it when this particular user who runs the reports or something like that gets his own custom set of Postgres settings. This is a good candidate for something to tweak in there. There are a lot of these query optimizer things that you can adjust on a per user basis in order to get good query plans out that you may want to make them very specific to the query return.
About the connections in your calculation, I've seen that a lot of people tend to put a real big max connection value.
Mm-hmm.
Is it calculation more based toward the max connections or toward the effective number of connections that will be on the database?
It's a good question. So the question is, do you set this based on the actual max connections or the effective average number of connections? The answer is somewhere in the middle, because you may set this to a larger number than you would normally like based. So the idea is this is intended to work off the max connections in the database, like the hard limit, and this is trying to get safe numbers, even if every single client is connected to doing something. That's the intention here. It may very well be the case with your workload. You may find yourself, if you really start getting detailed, this is not something you just want to do off the cuff, but if you need to, you can do things like say, well, look, I've got 500 connections to this database, and I know that these 10 users over here, they have queries that they run that need more work than the things that the other users do. And because of the way my architecture is built, there's never ever going to be more than 10 of these executing at once. And all of the other 500 are executing simple queries, right? So like that's the sort of thing that you're talking about is, well, what if some of the users are just different or the number of them you get at once is not the same? You may be able to get away with setting workmen to a higher value than you could support if every client was running a big computation. You might be able to get away with that if, because of your workload, you know, well, it's never actually going to be the case. I'll never get more than 10 users running this giant query, so the fact that I need to set workmen higher for it, I'll do that globally, knowing that there are not that many of them are ever actually going to show up in your query. It's kind of a dangerous game to play, but that's what we can do it. If you want to put setting this up per user in the versions that becomes available, I think is probably what you want to do with this parameter. In the long parameter, they want this entire, everyone wants this entire mechanism to go away for this specific parameter. So start with the discussions. As I said, the tuning the PostgreSQL server goes over about 4 times as many parameters. It starts with these and goes into a bunch of other ones. But these are the things that, if you get them, that they will almost certainly be wrong out of the box. And you will but just getting them into the right sort of ballpark, either by hand using the instructions in the tuning guide on the wiki, or running pgtune to spit them back out again, will get you to the point where you're more likely to run into some other problem than to run into one of these limitations is the first thing that we identify. Table statistics. This has already been touched on if you were in the earlier talk today. So table statistics are sometimes the answer to one of the more popular performance questions that pop up, which is, well, why didn't this query use an index? So there's a couple of reasons why a query can fail to use an index. The simplest one is simply the fact that it's not actually any faster. Postgres uses a